So back to the implementation of is prime. Or we can comment this, compute whether the number is prime. Is prime. So I will use a for loop to introduce the for loop and also to try to save this problem. I'll say, how about this? If I have an integer and I can name it divisor, maybe, and start with the 2, with the value of 2, and then say the plan is to be able to take the candidate, right? So the plan is to take the candidate, divide it by the divisor. That's the plan. And then take the remainder of that division, and of course that operator is expressed as the percent sign. It's an integer division which executes the division, throws away the result, instead returns back the remainder. If, of course, the rules say, if the candidate will be divisible evenly, the remainder of the division will be 0. There will be no remainder. In that case, I can say that if somehow this is true, the division is not equal 0, for example, the result of dividing candidate by the divisor is not 0, then instantly, immediately, return false. As soon as this happens, that the result of this division is not 0, we're done. It's not a prime. Yes, I'm sorry. If it's 0, then it's no longer a prime number, right? Because there's no remainder evenly divided by something else other than itself and number 1. So we return false. The math also says that if the number, and we're really expecting only positive numbers, so I'll just simplify it to say if candidate is less than 2, we also return false, because strangely 1 is not a prime number. By the way, for those of you who have submitted the homeworks, I wasn't penalizing if you were printing 1 because I didn't discuss it earlier on, but to be accurate, I'd like to say that we need to account for that. So checking the candidate right at the top of my method implementation simplifies my life so that I don't have to think about some weird cases around around numbers that are on the boundary or somewhere else. So I can be pretty confident about the candidate being 2 or greater. Okay, so hopefully that makes sense. And also, I would like to say that my plan is, if all of my tests went well, then at the very end of this method, I'm just saying returned true. So that's the plan. So now I need to supply divisors. I need to supply a set of divisors to this formula right here to test every single possibility and eventually decide whether I should return false or true. So I'm going to use for loop to say that the divisor is going to be set as Every time, I use a divisor, I'm going to increment it. So at some point, the divisor will increment. Okay. But before I increment, I am going to test a condition. I will use parentheses to begin with. That the divisor is less than, so the divisor begins at value 2, right? So the first time I'm going to test whether the candidate is divisible by this particular divisor. Now, my thinking is that it needs to be definitely less than the candidate. Okay, so perhaps this could be my first version of this program. So let's analyze it. We test this simple condition, less than 2, no. The answer is no, not a prime. We then say, let's introduce a set of divisors. We have the candidate. So we're going to say, all right, starting at 2, let's check this condition. And this is how the for loop operates. It has this initialization, like divisor equals 2, could be sitting right here, or even being declared right here. But I'm not doing it because my habit is to be more or less consistent across C and C++ and Java. I typically don't use the initializer and create a loop controlling variable outside of the loop and use just a semicolon in place of non-existing initialization statement inside my for loop. So the for loop actually contains those 3 parts. So if I resurrect this for a second, this would be the initialization statement. This will be the condition statement, similar to what we did with while, right? With the while, we said, okay, we have a while loop, and it would have a condition here, and there would be a loop body inside here, right? So this is like inside the loop. Okay. So in my case, with the for loop, the condition is occurring after the semicolon. And I told you that this initialization statement is optional. However, the semicolon is not optional. So if the condition is true, I immediately get inside the loop and begin my analysis of numbers and executing formulas. As soon as this condition becomes false, I will exit out of this loop and will hit the next statement. And the statement will be returned true. And I will get out of my is prime and return a true value. If I reach this ending of the for loop right here, if I reach this closing brace, and here's my opening brace, by the way, a lot of people actually, for the sake of visibility, place this opening brace here. I prefer to do it this way. I prefer to keep it on the same line. So at the end of this loop, of course, you know that I'm going to, if I found a way to reach the end of my loop, all that's going to happen next is going to take you right back to this line. Except that with the for statement, with the for loop, it will also execute this increment statement. So officially, we have, let me do it like at the top here. We have initialization, initialization statement, then semicolon, then we have condition, expression, and finally we have an increment or decrement. This value could change like this, plus, minus, increment or decrement. So I'll just use increment. So these are the three parts of the syntax of the for loop. Now I have this, I kept this in view. I'm about to delete it or maybe comment it out so it doesn't obscure what I'm doing right now. But remind me if I forget to show you the true difference between the for loop and the while loop, because they're very similar and yet they're not the same. There is a significant difference that does exist between them. Okay? Remind me if I forget to mention it. I would like to mention it. Okay, so I'm going to save this, and I'm going to save my recording right now.